Alright, today we're going to be looking at section 4.5, solving systems using inverse matrix. To get started, I want to take a look at this matrix multiplication problem up here, real quickly reviewing a few things about matrix multiplication. First off, that we have a 2-row, 2-column, or 2-by-2 matrix. It's the dimensions, and we're multiplying that by a 2-by-1. Of course, the matrix multiplication is defined if these middle two numbers are the same. That's the columns of the first and times the rows has to match the rows of the second, and we cross those out, and whatever is left is the answer. So we're going to have a 2-by-1 answer. Now this looks like it should be bigger than a 2-by-1, but I know how big this answer is going to be, so I just kind of made it really wide. But row 1, column 1, row 2, column 1 is what we have. All right. So in multiplying these matrix, I'll take the one on the left and break it up into rows. I'll designate this as row 1 and row 2. And of course here we have only one column, so we have column 1. And this is row 1, column 1 of our answer. So that tells us to take what's ever in row 1 and times it by what's in column 1. And to do that, we multiply the first in the row times the first in the column, or negative 3 times x, and that gives us negative 3x. And we add to that, and so always add between the second in the row times the second in the column, or 4 times y, which would give me 4y. All right, row 2, column 1 of my answer tells me to take what I have in row 2 and times it by column 1. First in the row times first in the column, or 2 times x. And add to that second in the row times the second in the column, so I'll add a negative y. Well, plus and negative is the same as minus, so I'll just write that as minus y. Now when I remove the brackets from this 2-by-2 matrix, then it looks very similar to the left-hand side of our system of equations that we're about to work with. Okay, so clearly then this can be written as this 2-by-2 times this 2-by-1 if we choose to. Well, that's what we're going to do. All right, let's move on. If we want to, we can change a system of equations to a matrix equations by doing the following. So here's our system, and again, we've already worked with this left-hand side, and that's going to become this 2-by-2 times the xy that we had up here. And I'm just going to, for this example, I'm going to call this 2-by-2 matrix A, and this column matrix xy, I'll call that x. And then we take the constants over here and we just make a column matrix out of them, and I'll call that B. So this thing can be represented by A times x equals B, and then to solve it, we want to find the inverse of A and multiply both sides by it. So I do that in the next screen. Let's look. This one's a little bit busy, so I'm going to bring up this right here, and let's just only look at part of it at a time. Okay, so here's the matrix equation that used to be the system of equation that we want to solve. Okay, so we said that we would take and multiply both sides by the inverse of A. Now, by definition, the inverse is 1 over the value of the determinant. Okay, so let me show you where I got this negative 5 from. The determinant of A is found by starting in the upper left and multiplying the numbers down to the lower right. On this diagonal, we multiply those numbers, negative 3 times negative 1, and we always subtract in this in the process of finding determinant, and we subtract the lower left times the upper right, or 4 times 2. Okay, well, negative 3 times negative 1 is positive 3. Bring down the minus. 2 times 4 is 8. And 3 minus 8 is negative 5. So we put negative 5 under here, and that completes this fraction. Okay, and if you need to go back and look at earlier lessons about how to find inverse, they can be found on YouTube as well. And then we times that by another 2-by-2 matrix that's comes from the A matrix, or whatever we find the inverse of. So you'll see that green line over there. We said these have changed places on this diagonal. So notice where the negative 1 and the negative 3 came from. Well, of course, they changed places. So those reverse. And on this diagonal, well, they just changed signs. So the 2 became negative 2, and the positive 4 became negative 4. Now that comprises the inverse of A. It's the product of this fraction times the changed matrix. Matrix. All right. Okay, second, we want to place the inverse in front on both sides of the matrix equation. So let's take a look at that. Okay, so right here in black you see the original matrix equation that we wanted to solve. Now in front of it, or on its left on each side, I've placed what we've defined up here as the inverse of A. Okay, now I want to talk to you about this left hand side. What we're doing here is we're taking a matrix A and we're multiplying by its inverse. Okay, well, in a previous lesson we've discussed what happens when we do that. So by definition, a matrix times its inverse is the identity matrix, and of course the identity matrix would look like this. I don't have much room here, so I'm just going to scratch it in over here. Okay, so the 2 by 2 identity matrix would look like this, and that times anything yields itself. So it's kind of like the multiplying by 1 in real numbers. For a matrix, it's the identity matrix. So what we're going to say is that all of this became this matrix, and that matrix times x over y gave us x over y. So the work on this side, after we write it out, and yes, you have to write this out, and then you can cross it out and say it cancels. Okay, so where we get our answer from is going to be on the right hand side. Now here we have a fraction times a 2 by 2 times a 2 by 1. What you want to do is you want to multiply the two matrix first and then come back and times by the fraction. Okay, so multiplying the 2 by 2 times the 2 by 1, we break this up into rows. First in the row times first in the column, or -1 times 5 is -5. And we add to that second in the row times second in the column. -4 times -10 is 40. And when we add those two together, we get 35, and that's where our 35 came from here. Row 2 times column 1, -2 times 5 is -10, plus -3 times -10 is 30. -10 and 30 is 20, and that's where the 20 came from. So all we have to do now is to multiply this scalar times the 2 by 1 matrix, and simply just distribute it to both of them. When we take -1/5 and we times it by 35, we will get 35 over -5. Okay? And this should be -7 right here. So we'll just cross that out. Somehow I changed that earlier and it didn't take. So -35 over, 35 over -5 is going to give us -7. And then when we take the -1/5 and times it by the 20, we'll get 20 over -5, which gives us -4. And so we have this equal matrix here. So x has got to equal -7 and y has to equal -4. And that's our solution. Okay? All right. Let's take a look at this one. Want you to solve this matrix equation. Okay, I'll give you some time. We'll stop the video and then we'll come back and look at the answer. All right, assuming you've had time to do that, we'll go ahead and unveil the first part of this. Okay, so we're going to have to find, so clearly then the A is going to be -2, 3, -5, 2. And our first step is going to be to find the inverse of that. Well, we had to find the determinant of A, which was going to be the determinant of -2, 3, -5, 2. Multiplying going down, -2 times 2 is -4. It's always subtract. Multiply going up. 3 times -5 is -15. When we have minus a negative, it's plus a positive. So it's going to give us 11. So that's what went down here, was the determinant of A. And then these two, they changed places. You could confuse that with changing signs since they both have a 2, but they actually changed places. And on this diagonal with inverse, they changed signs. So the +3 became -3, and -5 became +5. So this is our inverse right here. And that's going to get put on the front. That's going to be put here and here. And of course, what's left is our original matrix equation had we changed that to a matrix equation. So, all right, so let's complete that. Of course, we just talked about what happens over here. This side's going to cancel. It becomes the identity matrix, and that times xy is going to give us xy. And then on this side, we choose to multiply the matrix before we do the fraction. So multiplying the 2 by 2 by the 2 by 1, 2 times negative 19 is negative 38, plus 5 times 1 is 5, and of course that gives us negative 33 right here. And negative 3 times negative 19 is 57, plus negative 2 times 1 is negative 2, and that gives us 55, and that's where the 55 comes from. Then now we multiply through by the by the 1/11th, and we're going to get negative 3 and 5. So x is negative 3 and y is 5, and if we chose, we could put that in a ordered pair form. Okay. All right. So some more practice with write the linear system as a matrix equation. This is kind of mirror our homework problems. So I'm going to give you the system of equations. What you'll have to do is what I have in blue is write as a matrix equation. Well, we've got some missing numbers over here, so I'll go ahead and put them in so you can see there is a 1 in front of that, and there's a 1 in front of this y. So if you take the x's and the y's out, you have 1, 4, 2, negative 1. You put them in a column matrix, and we've already shown what this will yield. If we multiplied these two together, we would get this right here, and then of course the 6 and the 5 we put in a column matrix. That's all there is to changing from a system of equations to a matrix equation. And here's an example of a 3 by 3. Again, the missing numbers are 1 and 1 and 1 and 1, and I think I'm missing a negative right here, I notice. Okay, so when we take the x's out, we're left with 3, 2, 1. We take the y's out, we have 1, negative 1, 4, negative 1. We take the z's out, we have 4, negative 1, 3. And the x, y, and the z go in a column matrix, which if we multiplied, we would get this right here if we multiplied that out. We've shown that earlier. And then this we just simply put into a column matrix. Okay? All right. Get you to try one. Go ahead and write this as a matrix equation. Okay, well, when you take the x out and just leave the coefficients, it's 2 over 1, and then from the y's, negative 5, negative 3. Next to that, the column matrix, xy equals 4, 1. All right, here's another one for you to try. A little hint on this one, you have some missing variables. If a variable's missing, the coefficient must be 0, so you'll have to supply zeros for anything that's missing. Okay, let's take a look at that one. All right, the coefficient of x in the first equation is 1. The coefficient of x in the second equation is negative 1. The coefficient of x in the third equation, since it's not there, is 0. Now we go to the y's. The coefficient of y in the first equation, it's not there, so it's missing. It's a 0. The coefficient of the y in the second one is negative 1. Coefficient of y in the third one is 7. Coefficient of z in the first one is positive 1. And there is no z in the second one, so it's a 0. And the coefficient of z in the third one is negative 1. So this time we'll notice that they weren't neatly in a row here at all. It didn't go 1, 1, 7 over here. It's kind of skipped around. So you had to put zeros in for what was missing. And then we supply the variables in a column matrix x, y, z. If we took the time to multiply these two, we would get this right here, or its equivalent. And then the constants get put in a column matrix 9, 6, negative 4. And we've changed the system of equations to a matrix equation. Okay, not sure why this comes up that way, but it's been a pain in the neck all day here. Let's move this down real quick. All right, now we can see it. Okay, so here we want to practice another kind of problem that we're going to see in our homework, and that is I give you a system of equations in 3 variables, 3 equations, and I provide for you the inverse of the matrix equation. Excuse me, the coefficient matrix is what I meant to say. Now, we know how to find the inverse of a 2 by 2, but there is not a process that I've shown you to find the inverse of a 3 by 3. So if we ask you to solve a matrix equation, a system of equations with matrix equations, and it's 3 variables, 3 equations, we'll have to provide you the inverse, and of course this is it. Okay, so step 1 would be to write this as a matrix equation. So we'll do that, and I'm going to think forward to know that I'm going to have to put this in front. So I'm going to put it right here. I'm going to leave some room in front of this one, and I have 1, 0, 2, and my y's are going to be 1, 2, 5, and my z's are 1, 5, negative 1. And then I'll have my x, y, z here as a column matrix, and that equals, now I don't want to put my column matrix right here because I want to make room to put this in front on both sides. So I'm going to leave room for that. I'm going to move over here and write the column matrix 6, negative 4, 27. Okay. Step 2 would be to take the inverse that was provided. Now we didn't have a way of finding it, but if it's given to us, we know what to do with it. We put it in front on both sides. So I'm going to go ahead and do that. Okay, didn't want you to sit there while I wrote this in, so I went ahead and put the inverse in the front on both sides. Now, this is A, and this is the inverse of A. And theoretically, when you multiply A times its inverse, you get the identity matrix, and the identity matrix times this is going to give you X, Y, Z. All this cancels, and so we have on this side, we have X, Y, Z equals, and we save the fraction for last, and now we multiply this 3 by 3 times this 3 by 1. It's possible you get a 3 by 1 answer. There's our answer blank. Okay. So we'll go ahead and multiply these out. So we'll do row 1 times column 1 here. Okay, I've already done that for us here. So negative 27 times 6 is going to give us negative 162 plus 6 times negative 4, negative 24 plus 3 times 27, 81. You add that together and you get negative 105. Okay, now row 2, column 1 of our answer, we'll do that multiplication. Row 2, column 1, change that to column 1. Okay, and that's going to equal 10 times 6 is 60 plus negative 3 times negative 4, positive 12, plus negative 5 times positive 27 is negative 135, and we add all this together and we get negative 63. You can do that in the calculator. Okay, and now we'll do row 3 times column 1 right here. All right, negative 4 times 6, negative 24, plus negative 3 times negative 4, positive 12, plus 2 times 27, 54. Add those up in the calculator, and that'll give us 42. Okay, all we have to do now is multiply through by the negative 121, 1 over 21. So we get X, Y, Z equals, so 105 over 21, negative over negative is positive, and that's going to give us 5. Negative 63 over negative 21, that's going to give us positive 3. And 42 over negative 21, it's going to give us negative 2. We got the equal matrix, so X is equal to 5. y is equal to 3, and z is equal to -2. All right, well, that's going to conclude this video, and I'll be making an assignment for the class. Thank you for watching.